Okay, so today in class you practiced factoring using the greatest common factor. So you had a polynomial, you factored out the greatest common factor, and then what was left after that, and those were your two factors. Today we're going to be factoring something by doing something called either the four-term grouping method or we're going to use the box method. I'm going to show you both, and then when you go to do a problem on your own, you can pick either one you want. It doesn't matter. They both work. They both get you to the same answer. It just depends on what you prefer. It's a personal preference. I don't care either way. So I'm going to do the first example using both methods so that you can see they always get you to the same answer, and then the next few examples I'll alternate back and forth. So using the box method is exactly what it sounds like. You are going to draw a box, and I'm going to draw a prettier box. That's sort of ugly. So the first thing you want to do is draw a box. And because this has four terms, you want a box that is broken up into four segments, just like a window pane. So that's sort of like what you're making is just a window pane. And we're going to fill in this box with the terms for my polynomial. So the first thing here is 3x to the third, then minus 4x squared, then 6x, and minus 8. And then I'm just going to go through here and pull out the greatest common factor row by row and column by column. So this row right here, 3x to the third and negative 4x squared. Well, the greatest common factor for 3 and 4 is just going to be a 1. And then for x cubed and x squared is an x squared. That's what they have in common. Now this bottom row, I have 6x and 8. The greatest common factor between 6 and 8 is always going to be a 2. This 2 will go into both of those numbers. And then my greatest common factor for this column, I have 3x to the third and 6x, is going to be 3x. And then this column, since both of these numbers in this column are negative, I have to factor out a negative number because both of them have a negative in common. And so now I'm going to factor out a negative, and the greatest common factor for 4 and 8 is going to be a 4. So my two factors for this polynomial are going to be 3x minus 4 from right here, and then x squared plus 2 from down the side. If you want to keep the 1 in front of the x, that is fine, but those are the two factors for that problem. Now the grouping method is just like the box method, just written out in a long pretty little in a long pretty little line instead of in a box. So here's what the grouping method looks like. You have your polynomial, and just like the name of it says, we're going to group. So we're going to group these first two together, and we're going to group the second two together. And then we're going to pull out the greatest common factor for each of these little groups and write them down. So the greatest common factor for 3x to the third and 4x squared is going to be 1x squared. And if I factor out a 1x squared, 3 divided by 1 is 3, and then x to the third and x squared, I still need an x here, minus 4 divided by 1 is 4. I have the x squared already, so I'm good. Put your plus sign because that's what's here. Now the greatest common factor for 6 and 8 is going to be a 2. And if I factor out a 2, 6 divided by 2 is 3, and I need to keep my x. Then 8 divided by 2 is 4. Now what you should notice is that the parentheses have the same exact thing inside them. This is an instant check for you. If your parentheses work out and they are automatically the same, you are good to go. If you do this and your parentheses end up with different things inside, then you have made a mistake somewhere. So this is an instant check, and this tells you that one of your factors is 3x minus 4. Just like one of my factors here was 3x minus 4. My other factor is what is not in parentheses, so it's what's left here and here. So my other factor is x squared plus 2. And you can see these are the same two factors as these two. I only changed colors so I could underline, but the same two factors that I got here, so it doesn't matter which method you use. So let's do a couple more examples, and I'm going to alternate between box method and grouping method so you can see both in action. So this first problem right here, number 2, I've got 7x to the third plus 2x squared plus 28x plus 8. I'm going to group, so I'm going to group the first two and the second two. So step 1, after you've grouped them, find the greatest common factor for each little group. So this first group, 7x to the third and 2x squared. The greatest common factor for 7 and 2 is a 1. And for x cubed and x squared, it's going to be x squared. We'll 7 divided by 1 is 7. X cubed, x squared, I still need an x. 2 divided by 1 is 2, and the x squared is already taken care of, so we're good. Plus. Now the greatest common factor for 28 and 8 is going to be 4. 28 divided by 8 is 7, and I still need the x. And 8 divided by 4 is 2. Now the stuff in parentheses matches, so one of my factors is 7x plus 2. The other factor is what is not inside parentheses, so it's x squared plus 4. So let's do the next one. We're going to do this one using the box method. And so the first thing we're going to do is we're going to draw a box. And we're going to separate it into 4 equal parts because I have 4 terms. And then we're going to fill in the box with our terms. So I have 2d to the third minus d squared. Now here needs to go the d. These are in the opposite order, so it needs to go from biggest to smallest through the box. So d cubed, d squared, 6d, and then negative 3 without a d. So it should always go in order: d cubed, d squared, d, and no d, or whatever the numbers are. The biggest one here, the smallest one ends up down here. Now we're going to pull out greatest common factors. So this row right here, my greatest common factor for 2d to the third and d squared is going to be a 1d squared. Then this row down here, 6d and negative 3, the greatest common factor here is going to be a 3. And then for this column, the greatest common factor is going to be 2 and a d, because 2 and 6, greatest common factor is 2, and then d cubed and d is a d. This column, since they're both negative, my greatest common factor is going to be negative. And there's a 1 here in front of this, so the greatest common factor for 1d squared and 3 is just going to be 1. So the two factors for this problem are going to be d squared plus 3 from the side right here, and then 2d minus 1 from right here. These two things multiply together to give you this polynomial. So let's try just a couple more just to make sure we're all on the same page. So this problem right here, we're going to do using the grouping method. Nope, I want to do the box method. And here's why I want to do box method with this. This right here has, well, first of all, it's out of order. So the first thing I'm going to do is put it in order. So the variables, like I told you, the exponents go in order from biggest to smallest. So you have 12a to the third minus 9a squared plus 20a, then minus 15. Now I will do the grouping method. I said I wasn't, but I changed my mind. So now we'll group. So the greatest common factor for this first group, for 12 and 9, is going to be 3. And then for a cubed and a squared is a squared. Now 12 divided by 3 is 4. I have a squared, but I've got to end up with a to the third, so I need an a. 9 divided by 3 is 3, and the a squared is taken care of, so there we go. Now, the greatest common factor here for 20a and 15 is going to be 5. 20 divided by 5 is 4. You need the a still, and then 15 divided by 5 is 3. My parentheses check out, so one of my factors is 4a minus 3. The other one is 3a squared plus 5. Now number 5, everything's all in order, everything is good, but I'm going to use the box method for this one, and the reason I'm going to choose the box method is because I have a negative at the front for my leading coefficient, and then this minus sign in the middle will sort of mess with things. So the box method is going to be a little easier for me here. So I'm going to draw the box, and I'm going to make 4 segments because it's got 4 parts. And then I'm going to fill in just like before. So I have negative 10b to the third, 16b squared, minus 25b plus 40. And I'm going to factor just like before. So the greatest common factor for this row right here, for 10b to the third and 16b to b squared, is going to be 2b squared. The greatest common factor here for 25b and 40 is going to be 5. The greatest common factor for this column, they are both negative, so I have to factor out a negative because they have that in common. And then for 10b to the cubed and 25b is going to be 5b. And then for this column, I have 16b squared and 40. The greatest common factor there is going to be 8. So my two factors for this are going to be 2b squared plus 5 and negative 5b plus 8. So those would be your two factors. So that's factoring using either the box method or the grouping method. Either one works. Like I said, it doesn't matter which you choose, and you can alternate between the two. Just whichever works best for whatever problem you're on. This is what we will practice tomorrow when you come to class. I will see you then.